Hi everyone, welcome back to K Science Academy. If you are just joining us for the first time, this is K Science Academy, where we talk about physics, chemistry, mathematics, and science facts. You are all welcome. Now, I promise I'm going to send a question on stress and strain. So, we are here today to solve the question together. We said we have a force of 40 Newton applied at the end of a wire of length 4 meters and diameter 2 millimeters. Process an extension of 0.24 millimeters. Then we have to calculate 1. The stress on the wire, 2. The strain in the wire, given that pi is 3.14. So these are the information we are going to use to solve this particular question. So one thing that is really important in solving any physics question is for you to write out your parameters. Here we have the force, we have the length, we have the diameter, we have the extension. Those are all the parameters given to us. Now we are asked to calculate the stress, and that's the first part. And you could remember stress equals to force over cross-sectional area, but here we are not given the area directly, and that's why I intentionally picked this question. So but when you are talking of a wire, when you check a wire from one end and you check it at the other end, you see that you have a circular part towards the entrance where you have the wire. I'm not talking about the rubber they use to cover the entire wire, but when you look at a wire from one end and you look at it from the other end, you will see a circle. So our area is going to be in form of, that is where the force acts on that particular circular part. That's why you call this cross-sectional area. So our area is going to be pi r squared. Now this question does not give us anything related to radius, but we have our diameter, and you could remember from your elementary mathematics, radius equals to what? Diameter over 2. Now the diameter given to us is in millimeter. Then don't forget the SI unit of anything related to length in physics is what? Meter. So we have to convert it. So if we have our diameter to be 2 millimeter, then that's going to be 2 times 10 raised to power minus 3 meter. So don't be surprised with this conversion. Milli is simply 10 raised to power minus 3, or you divide 2 by 1000. So if you divide 2 by 1000, just use your indices. That's 10 raised to power minus 3. So now we can now say, okay, our radius is going to be 2 times 10 raised to power minus 3 over 2. And in that case, we are going to have what? We are going to have 0.001 meters. And that's the same thing as 1 times 10 raised to power minus 3 meters. So we can now go back to the entire formula. Stress equals to force is 40 Newton divided by our area is now pi. The pi given to us is 3.14 times our radius all squared, that's 0.001 meter all squared. So if we do this correctly, we are going to have 12.74 times 10 raised to power 6 Newton per meter squared, because this is a meter, you see, all squared, then this is Newton. Now if we have to calculate our strain, we have our strain. Don't forget, strain is extension over length, and that's the same thing as change in length over your original length. Now what is our change in length? The final length minus the initial length over the original length, the final original length. So now we are given the extension directly, so we don't need to know the difference between the final, we don't need to find the final length and the initial length. Just that we know the initial length from the onset, that from the question our initial length is what? 4 meters. Then the extension of the wire is 0.24 millimeters. So converting this also, you have extension is equal to 0.24 times 10 raised to power minus 3 meters. So now from this we have our strain to be equals to our extension 0.24 times 10 raised to power minus 3 meter over our length, which is the original length given to us, which is 4 meters. So you see meter cancel meter, that's why strain is unitless. So if we do this correctly, we are going to have 6.0 times 10 raised to the power of minus 5, no units. So this is our strain and this is our stress. So thank you. We are going to see in the next video where I'm going to explain the Young modulus So see you in the next video. Bye.